Okay. So, yeah, so we are resuming our weekly classes from today. So I think we all have gone through the syllabus, right? In the first class itself, we have gone through the syllabus, and then we have discussed the approach, how we are going to proceed with this course. Okay. I hope you are remembering that. Basically, we are starting with the prerequisites to start with robot programming. Okay, so that's actually a big list. Okay, so if you're trying to learn rows directly, then what happening is that there are some that you have to learn before. Like if you want to build a robot and if you want to program it, there are a lot of things to learn, right? Before starting with rows. So that's what I am trying to cover in the beginning. Okay, so that is what you are seeing in the warming up prerequisites for robotics and rows. Okay, so which is very important because you guys are from different backgrounds. Some of you are from mechanical or electrical, electronics, computer science, right? So those who are working in computer science may not have idea about mechanical or like electrical. So there is some issues when I'm taking the classes in rows, and if I'm discussing, for example, electronics, okay, some basic electronics, then some of you don't know about electronics. Okay, so that is the gap that I'm trying to fill initially. Okay, then we will be starting with rows. Okay, so I know some of you are already aware of the basics, okay, that I know, but I think I will say it will be very good if we can just go through the fundamentals very briefly, okay, in order to avoid the confusion. Okay, so in the first lectures we have seen the robotics, basics of robotics. I just gone through very basics of robotics, like different kind of robots, what is a robot, then different sensors, actuators, what is robot programming, and all. And after that I took actually a vacation. It was a 1 month vacation because I was in another work, several works actually. So one of the work was this book. Maybe I can share this work. This was actually a 2 year work. Okay, so you can imagine. I'm not the author of the book, but I actually one of the editor of this book. Okay, so there are a lot of work involved, and I think we have started I think in 2020 or something. Okay, and the book actually teaches about autonomous driving. Okay, it's not about what is autonomous driving, but it's about like legal issues, testing, how to test, then development, application, those kind of thing. So it consists of several papers, okay, submitting by, from different universities. Okay, you can see these articles. I think there are 34 papers you can see. Okay, so we have to coordinate all these things. The reviewing, then so some of the papers I have reviewed, and yeah, so there are a lot of process involved. So what I did was, after this work, when the book completed, I plan to take a vacation, but at the same time I have to run the course. So my plan was like like in parallel we just started with the robotics, right? We just started with the robotics, and I'm pretty sure that these basic stuff are not enough if you are like planning to pursue your career in robotics. So I discussed with my course members. It's not course member. There are two people, right? Jarin and Rajesh. I discussed with them, and then we plan to create a set of assignments, okay, which will be useful for you for sure if you are planning to pursue a career in robotics, and it's not related to the application side, but mainly about the theoretical aspect that you should know. Okay, so we have created a set of assignments that actually, I think some of you have tried. It will be very, very useful. Uh, uh, Mainly Rajesh and Jarin was involved on in crafting these assignments, and I'm very impressed with these assignment questions. You can access these assignments. I think, yeah, 7 assignments. One assignment is currently going, and you can find the solution and all from this same GitHub. I have uploaded all the assignments, videos, and you can, if you press view solution, it will be directly going to the PDF. Okay, it will be loading. Okay, so from the assignments you can find we are discussing from like the history of robotics, and yeah, it's all very relevant question. It is having, I will say, some practical aspect as well. Okay, so I think it will be a good experience for you to work with these assignments, and mostly the assignments are like put in the Google form, so you can just like this, you can just fill it up. Okay, then Rajesh will check and give some feedback. Okay, so that was the plan. So I think these assignments will be there always, so you can refer it if you couldn't able to do it. Maybe whenever you get time, it will be good. Even I have checked the questions, and some of the things I don't know, some of the things mentioned in the assignments, because I forgot a lot of things, because mostly we know the things that we are currently working, right? So before the session I was just going through all the assignment questions, and it was like, I mean, refreshing. Okay, especially like when we work with just a sec. Yeah, the coordinate frame, which is very useful while working with rows. There is a thing called TF in rows, basically stands for transformation. So when we work with TF, you need the fundamentals of these transformation metrics and coordinate frame, all those stuff. Okay, so that is day 5, and then if you are going with day 6, just a second. Yeah, kinematics. Yeah, and yeah, different kind of robotic arms. Yeah, that is good. And then homogeneous transformation metrics, forward kinematics, DH parameters. Yeah, so again, very important concepts. Then on day 6, no, day 7, that is currently going, I think, which is this, or let me check. No, day 7 is different. Yeah, it's mainly about inverse kinematics. Okay, very important when you're planning to work with robotic arm. Okay, so I hope you you have, I mean, you have at least tried to do. So do you have any comments related to the assignments? I just want to know your feedback, how to improve the assignments in future, if you are planning to put some assignments. So just want to know your feedback. So if you have any suggestion, please let me know now. You can just unmute your mic and you can talk. Any suggestion, guys, to improve the assignments, or what is your feedback while doing these assignments? Can anyone talk about this? Anyone? So I hope you have done, I mean, some of the assignments, right? I'm not hearing from anyone. Can you hear me, guys? Yeah.
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 It's fine, sir.
Okay.
Uh,
Okay. Good. Okay, so that was a initial plan, like for the month of December, and even there are a lot of celebrations going on, like Christmas, New Year. So we have to take some I mean, leave, of course. Yeah, so I think this is useful for sure for you. Okay, for some of you who already know robotics, I think it can be a refreshing thing, I will say. Okay. Yes. So I think we have completed the first part, that is introduction to robotics. Okay. This is one of the chapter in the warming up session. Okay. That is the introduction to robotics. So just focus on the coordinate frame, then forward kinematics, inverse kinematics, those kind of stuff, which will be useful while discussing rows. Okay. Maybe I can directly show you what we are going to do with this stuff. So there is a thing called TF, so you can directly understand. Just a sec. Yeah. So I'm just sharing. Okay. So you can see the coordinate frames here. Okay. So this is actually a library in rows, which is handling the coordinate frames of all the joints in the robot. Okay. So while dealing with this library, of course, you need to know the basics of robotics. Okay. I hope you understand the point. It's not for the sake of giving the assignments. It's actually very useful while working with rows. Okay. I hope you understand. Okay. Okay. So now we can jump into the next chapter, which is basics of electronics and embedded system. I'm not teaching lot of stuff, but I know what are the basic stuff we need to build a robot. Okay. So maybe I can also show you a robot that I have now. Maybe just a sec. I can also talk about that. Just a second. Let me just move the robot here. Okay. It's actually for another book which will be released on February or March. Okay. It's called okay. Doesn't have much clarity, I guess. Just a second. Okay. I think now it's much better. Okay. Let's see. Okay. I think you can able to see some part of the robot. It's a very basic robot. Okay. Maybe I can just move the camera, but this is my computer desk. Okay. Just want to. Okay, so it's all not wired perfectly. It's actually, there is a book called maybe I can show you the book as well. Just a sec. Okay. Rows for Absolute Beginners, and the second edition. So it's not released yet, but the page is actually live. Just a sec. Couldn't able to find, but it's there. Yeah, anyway, like the second edition is going to release on March. Okay, so this robot is actually for just a prototype. The book is for absolute beginners, right? So I'm just using a very basic robot in order to work with rows, and how to interface these robots to rows. So those kind of stuff are mentioned in the book. Okay, I'm just correcting. Okay. Yeah. Okay, I think this would be fine. So there is a robot, and I have a kit as well. Okay. I have a big kit here. Maybe I can take one by one while teaching. Okay. So I have a basic electronics kit. Okay, so that you can use to prototype robots. like soldering iron, all those stuff. I will explain one by one. Okay. Yes. So let's start with the basic electronics. Okay. Let me close. So what we are planning to discuss is some of the essential things of electronics that is required while prototyping a robot. Okay. You all know, right? Robot is not only a mechanical device or like mechanical machine, but it is having some electronics parts. Okay, so in order to work with electronics, obviously we need to know some electronics and electrical circuits. Okay, so I'm planning to discuss the basic electronics first, then some of the main components. Then tomorrow we can discuss about like the IO boards or single board computers that we can use for robots. Okay, so that is a plan. Okay, so yes, let me take some reference. Okay, so before that I just want to ask, how many of you are like very interested in electronic circuit? I mean, how many of you are very passionate in electronics? Anyone who are very interested in electronics in our group? Can you just comment, or like can you just say, I mean, anyone who are passionate in electronics, just electronics or electronics or embedded, whatever? Anyone in the group? Okay, I think I'm not seeing. Okay, Rajesh, yeah. Obviously, yeah, Rajesh and Jiren, maybe they're very interested in working with. Yeah, okay, I got it. And now how many of you are not aware I mean, they don't know electronics? I mean, how many of you interested in electronics? You can just comment, no problem. So just mention you are interested in electronics. And if you're not, I mean, if you don't know anything, you can also just comment, I don't know electronics, because I just want to know your knowledge level. Okay, if you are considering you as a very beginner, you can also comment. Okay, I need your feedback, because then only I can I mean, customize my session. Okay, so yes, okay, thunderclap, I think I forgot name. Rohan, yeah, sorry, Rohan. Okay, Hari, yeah, Hari is very interested and passionate, very good. Rohan, okay, don't know, okay, pretty fine. I think Rohan is having mechanical background. Then Jitnya, basic knowledge, fine. So for others, yeah, I'm just waiting. I can just take this thing. Okay, so Ashit, he's mainly into software part of the robotics, but know the basics of electronics part, fine. Then Tejas, interested in basic knowledge, great. Then Karthik, not much interest, okay, yes. Then anyone else? I mean, yeah, I think I got some understanding about the team members interest. Okay, yes, yeah, I think, okay, have basic knowledge, okay, yes. So whatever your interest, maybe even if you're working on the software, even if you don't have any interest, but if you're planning to work with robots, okay, then I will say you can build a basic knowledge, at least a basic knowledge in electronics. Okay, a basic knowledge. Why? Because I will say you may encounter, okay, you may encounter some kind of electronics while you deal with robots. Okay, so understanding electronics is a part of a roboticist, I will say. I'm considering roboticists as a full stack, or like who are having an idea about all the field, okay, but not a master, okay, but idea about all the field, and maybe he can focus on maybe software or maybe embedded anything. Okay, so that is what I'm considering. Even I'm considering myself, I mean, focusing on the software side, but I'm very passionate in electronics and embedded, all those stuff. Okay, because my bachelor's are in electronics and communication, and then the master's is in robotics and automation. Okay, yes. So electronics, if you don't have much interest, I'm not like saying a lot of things, but only the essential. Okay, so before starting with the I mean the electronics or all the stuff, we just want to know some basic concepts. Okay, let me take a link. After that we can start. Okay, I can quickly go through this. Okay, so you guys maybe heard about like voltage, current, charge. Voltage and current is very popular, right? You may have use this terminology like 230 volt. We have the 230 volt. We are getting 230 volt, and current maybe like depend on the usage, maybe, and a lot of things, right? But I'm not still sure how many of you know the actual distinction between voltage and current. Okay, so can anyone say, like, you can even read this? Okay, I'm just checking your understanding of voltage and current, okay, and the charge. Okay, can anyone say what is voltage and what is current? Can anyone say? Even if it is a stupid definition, that is pretty okay, because we are actually like, I mean, discussing, and there will be problems, issues. No problem. Can anyone say what is voltage? I mean, you're at least dealing with this terminology, right?
Voltage is the potential difference between the 2 points in an electric field, while current is the rate of flow of electrons.
Rate of flow of
Electrons.
Yeah, makes sense. So what Arch is saying is that voltage is the difference, the potential difference. He used that terminology, potential difference of the charges, or maybe the electrons or whatever, and then the current is the flow of electrons or charges. Okay, that's a good definition, Archit. And yeah, so Tejas is saying voltage is cause, and current is effect. That's also good. I just want to clarify. Okay, there is a concept called charge. Okay, you know the electrons. I mean, the charge, positive and negative charge, right? I mean, and you may also heard about same force repel and opposite force attract. I mean, you may heard about. Okay, so the electronics is starting from the concept of, I will say, the charge, positive and negative charge. Okay, so it's mainly like whenever there is a group of positive and whenever there is a group of negative charge, for example, the positive attract negative, right? Okay, so this change, that is the group of positive charge and group of negative charge, create, I mean, an attraction, obviously, like, right? When you put the positive and negative, it will attract, right? So if there is a group of charge, then there will be a force of attraction, right? So this difference, I mean, the difference between the positive and negative, is called the voltage. It's actually a force. You can imagine, like, I mean, whenever the positive goes to negative, it will neutralize. That's how it is. Okay, so the voltage is actually the force that positive and negative charges having in order to attract. Okay, so if there is a more positive and more negative charge, and if we are in between, then we will get that force. I mean, the positive and negative charge is trying to neutralize between us. I mean, it will try to flow through our body and we will die for sure, right? So it will depend on the concentration of the charge. Okay, so the voltage is the force, okay, we can say the force between this group of positive and negative charge. Okay, so that is called the potential difference. Okay, potential difference between positive and negative. Okay, so you may have seen the batteries, right? Batteries is having a positive terminal and a negative terminal. Okay, so yeah, here it is. Maybe I can show you a simple battery. Yeah, so this is a simple 1.5 volt battery. You can find this is positive. Oh, this is positive, and this is negative. Okay, so when you when you connect the positive to negative, what happening is that the charges will flow and it's trying to neutralize. Okay, but the problem is when it neutralizes, it is also generating heat. Okay, so this condition is called short circuit if we connect positive to negative. Okay, so using this force, using the positive and negative, using the force between the positive and negative, we can do a lot of stuff. Okay, we can do a lot of, because it's a force, right? It's a force exerting by the charges. Okay, so that force we can use it for many purpose. Okay, so that is actually the thing called voltage. Okay, and the current is actually the flow of the charges. Okay, we know that there is a positive charge and negative charge. Okay, and whenever we connect positive to negative, what happening is that the charges will flow, right? The charges will flow, and the current is the rate of that flow. Okay, so just understand that these two terminology, voltage and current. Okay, there is a positive charge and negative charge. Okay, and whenever there is a group of positive and negative charge, there will be a potential difference, or like a force in which the force is actually the difference between this positive and negative charge in order to neutralize. I mean, whenever there is a positive charge and whenever the negative charge, it is trying to attract. Okay, it's trying to attract actually. So the potential difference, this force can be used in many ways. Okay, so that's why, like we have normally in India, we have 230 volt. Okay, so the potential difference is 230 volt, and the current consumption can be like 10 ampere. I mean, depends on the application. So just understand the basic terminology before we start. Okay, the voltage and current and the positive and negative. Okay, and then we know the batteries. Batteries are the source of voltage and current. Okay, you will get, for example, for this battery, you will get 1.5 volt. Okay, and the current also, like it depends, okay, on the application, but there will be limit. Okay, in short circuit means if we connect the positive and negative, the maximum flow of current will be there, and if there is a maximum flow of current, the heat generation will be higher, and that's how the fuse works. Okay, so whenever there is a short circuit, the fuse will burn out and disconnect the entire circuit. Okay, and you may also heard about the circuit, the terminology called circuit, right? Circuit simply means like a path, from positive to negative. For example, let me take one circuit, for example, just a sec. Yeah, like you can simply check the circuit. Circuit is like there will be a voltage source, and there will be some appliances that is consuming the voltage the consuming the current. Okay, and in this case, this is called an open circuit, which because it's not connected, it's not closed, or like the electron flow is not there, charge flow is not there, but here the charge flow is there. Okay, so this is a closed circuit. Okay, so basically you can say a circuit is like there is a power source and there will be some like some sensors or like some components, okay, on it. So that is the terminology called circuit. It's like a completion of an electronic charge path, okay, from a voltage source, the charges flowing and ending at the positive, maybe from negative to positive. Okay, it's just a travel. Okay, so if the charges can complete the path, then it's called a closed circuit. Okay, if it can't complete, then it's an open circuit. Okay, so we have checked about voltage, current, circuit. Okay, then some components that we are using in the circuit. Okay, so just want to like briefly go through these components. I hope you heard about resistors. Okay, anyone heard about resistors? I'm not sure. Anyone heard about resistors? Can you just comment? Resistors. Okay, Karthik. Yeah. So from the word itself, you can understand resistors are actually like it's resisting something, right? For sure. So resistors can limit the current flow or the charges flow anyway in any times. Okay, so resistors are like you can see this component, right? I'm not opening my camera actually, but I'm just using the images. You can see, right? It's a very basic thing, like you can see. So this can create a resistance, or like it will block or limit the amount of charge flow. Okay, so if you want to limit the amount of current flow, you can use a resistor. That's it. Okay, and there is some color coding in the resistor. You can see there are a red. So based on this color coding, you can compute its resistance. Okay, so resistance is the capacity to resist the current, and its unit is ohm. Okay, you may heard about Ohm's law or something. Okay, Ohm's law, which is saying the relationship between voltage, current, and resistance. Okay, so we will see that. We can just go through the components first. Now there is a variable resistor. Okay, it's also called potentiometer. Basically, we can adjust the resistance. Okay, so this will be also be useful. Okay, so it's not a fixed resistance. You can adjust the resistance. By adjusting the resistance, we can adjust the rate of the current. The current basically. Okay, then there are different kinds of resistance, like there are LDR. Okay, which is changing the resistance based on the light. Okay, so if you want to create a light following robot, for example, you can simply use an LDR. Okay, you can simply use an LDR, and based on the resistance, you can maybe you can just feed into some microcontroller or something. Okay, so LDR is there. Then another type of components. I'm just talking about some popular thing. Capacitors. Okay, capacitors, which is actually like it can store electricity. It can store the charges. Okay, that is what capacitors do. Okay, which is having two terminals, like resistor. Okay, and which can be charged, and there are many purpose for capacitors, like filtering. Then there are a lot of purpose capacitors, and its unit is farad. Okay, mostly it's like if you take ceramic capacitors, it's like picofarad or nanofarad. Or if you are using, there are different kind of capacitors actually. If it is electrolyte, then it's like microfarad. Okay, so farad is the unit of capacitor. Then there is a diode. okay, which is an interesting thing. Like it can detect the direction. For example, it will conduct or it will allow the charges in a specific direction. Okay, for example, here you can see the diode. Okay, this is a simple diode, so it will allow the flow in one direction. Okay, reverse direction is not possible. Okay, so if you want to allow the direction, it will only we can use the diode. Okay, and it will only allow the flow in one direction. Okay, I'm just going through this. Okay, and there is interesting thing called LED, which is again a diode. Okay, so which is doing the same purpose of the diode. Okay, allowing the current flow in one direction, but it will also emit emit light. Okay, so LEDs are mostly using for indication. Okay, there are different LEDs, I think you know, right? So there is a positive and negative terminal like diode. Okay, in diode the negative terminal is this, positive is this, like that. For LED, the longest terminal is the positive and shorter is negative. Okay, so only for LED, for resistor there is no positive and negative. Okay, because it's simply resist, right? For capacitors, some capacitors having positive and negative, like electrolyte capacitors, but this is a ceramic capacitor. This doesn't have a positive and negative terminal. So diode is having, then transistors, which is the basic foundation of any electronic circuit. I mean, if you check the processor, okay, that we are using inside the computer. Okay, so the basic building blocks of the computer processor is transistors. Okay, which is having three terminals, and there are two types of transistors, PNP and NPN, and which is basically using to control the electron flow based on the some current. I mean, I'm not explaining, but it is also using for amplifying signals. Okay, so this actually revolutionized electronics. Okay, invention of transistors actually. Okay, so a lot of things to discuss, but I'm just going through. It's just a familiarization of the component that we are using. Okay, then relays are there, which is like relay in the sense it's basically a switch. Okay, and we can control this switch. For example, if in our home there is a normal switch, right? Manual switches, mechanical switches, like we have to switch on, switch off, right? So in some cases, for example, if you want to do a home automation system, okay, and you are talking to Alexa in order to switch off a light. Okay, so how is that possible? I mean, we are not manually switching off, right? So that is actually possible using some kind of circuit called relay. Okay, so one of the circuit that we can use is, component that we can use is relay. Okay, so relay, this is actually a switch, but it can be controlled using a signal. Okay, so if you give a signal, or if you give a voltage like 5 voltage or something, the switch will be closed, and if you remove that voltage, it will be open. Something like that. Okay, so a switch that can be controlled electronically. Okay, that is relay. Then the important stuff, the integrated circuits. Okay, so this is what we are going to focus. IC, integrated circuits. So IC is nothing but it's an integration of a lot of electronics components. So we have seen resistors, capacitors, then diodes, LED. A lot of things we have seen, right? And it's not limited to all this. So all these things, okay, mostly can be prototyped or can be created inside an integrated circuit. Okay, an integrated circuit is basically a silicon chip. Okay, you heard about the silicon, right? So inside the silicon we can create a transistor, a resistor, okay, a capacitor, okay, everything you can fabricate inside. Okay, so the finding of IC actually revolutionized again transistors to IC, actually one of the greatest time in electronics. Okay, after finding ICs, then there are a lot of changes like processor, computer processor. Then nowadays in our mobile, right? We have system on chip (SoC), which is actually an IC, right? System on chip is having processor, then RAM, then GPU, everything on a single chip. Okay, so you can understand like the chip technology actually revolutionized the electronics field. Okay, and you can also see microcontrollers. For example, if you are aware of Arduino, okay, Arduino board, okay, you can see an IC here, right? This is an IC, okay, and this IC we can specifically call a microcontroller IC, okay, and this chip can be programmed. Okay, so just imagine a chip can program. Okay, its pins can be programmed. One pin can be like turned to on, which is like a 5 volt, then it can be off, that is 0 volt. Okay, so a chip can be programmed. So that is the next revolution. After finding the ICs, then we have microcontrollers, processors, right? So there are a lot of invention happening in the field of integrated circuits. So we will be mainly dealing with the microcontrollers. Okay, in our syllabus we are dealing with the microcontrollers and the microprocessors. Okay, so that is what we are dealing in robots. Okay, so we have many components, basic components. So I just discussed that for basic understanding of this, and then we will be going to the integrated circuits. Okay, so that is what we are going to discuss more. Okay, but understanding of this will be very, very helpful. Okay, so if you have any question, let me know. These all are very basic stuff, but if you don't know about it, you can just ask me now. You can ask questions. So these all are the symbols of various components. Okay, a circuit is this. You can draw a circuit like this. So a circuit, this is called the schematic diagram, okay, of a circuit. And then you guys also see, just a sec, if you want to prototype any circuit, okay, one of the best thing that you can buy is a prototype board. Just a sec. Oh, let me just move. So this is called a breadboard. What you can see is yeah, I just want to say, yeah, so you can see a lot of slot, right? So inside that you can just plug a point. Okay, maybe I can. So this is a wire, okay, and I can just put in one point, okay, and then I can put this in another. Okay, so in this breadboard, the column, the row is having same connections. Okay, so simple circuit can be prototyped using a breadboard. Okay, so this is very handy. You can put the electronics components, wires, and then you can power it up. Okay, so this is if you are planning to build any robots, electronic circuit, I think you can buy some kits. Okay, electronics kits. maybe I can show you a kit that I bought. This is available online. You can just search. Oh, let me just, okay, just a sec, let me twist it. Yeah, I hope that will work. Okay, you can see the kit, right? Oh. Next time, tomorrow, I think I can mount it properly. This is a microcontroller board which is having Arduino and everything. Okay, so I can just open it for you. So there are a lot of components that you can use for prototyping, mainly for robotics. Okay, you can see joystick, then displays. Okay, then yeah, there are a lot of things. Okay, so I just want to show you that. Maybe if you are like planning to prototype, I can send you the link of this kit. Okay, and then yeah, so I will be coming to the next points. So these are the icons of each components: resistor, variable resistors, transistors, capacitors, diodes, and all. Okay, so when you see a schematic, okay, of the robot, you could able to identify what are the components. Okay, at least you should have an idea. Okay, and then yeah, I just want to no, I'm not going to Ohm's law now, but yeah, you can see a simple circuit here. Okay, here you can see there is an LED, there is a battery. This is a 9-volt battery. Let me check. I have that now. Okay, I have that, but I didn't take it actually. Yeah, so this is a 9-volt battery, and then using this battery, I'm powering this LED. Okay, so that is what it's showing. This is a circuit. Okay, so in between, I just want to inject the Ohm's law here. Okay, so we already discussed about the resistors, right? Resistors. And what was the purpose of resistors? It was just controlling or limiting the flow of charges or current in specific. So if you want to power or if you want to connect a 9-volt battery to an LED, okay, the current rate or the current that can flow through an LED is actually very limited. Okay, so when you buy an LED, you can check the current flow, current limit through that LED. Okay, so if that current exceed or the voltage exceed, then the LED will burn out. Okay, so if you are connecting a electronic component with a power supply, okay, this is basically a DC power supply. Okay, there is two kind of power supply, AC and DC, alternating current and direct current. In electronics, we are mainly using the direct current. Okay, we will be mostly like converting the alternating current, that is the common current that we are that is available, like 230 volt AC. Okay, we have in home, we have 230 volt AC, right, which is get converted into DC. Okay, and then yeah, that is actually using in the electronic board and everything, in microcontrollers, processors, in computers, the conversion is happening. Okay, so this is a 9-volt DC, okay, which is a battery, and then other than LED, we are using a resistor here. So what will be the reason for putting a resistor in the loop or in the circuit? What will be the reason? Can anyone say? What will be the use of the resistor? Why we are putting a resistor here? Yeah, Karthik.
To reduce the current flow.
Yeah, exactly. So yeah, so what Karthik mentioned was correct. Like there is a specific specification for the LED. So what we are doing is we are putting a resistor in order to control the current. Okay, otherwise what happen? It will burn out. Okay, so how to decide this resistance? How much resistance we want in order to power this LED, or yeah. Okay, so that's what Ohm's law says. Okay, it's very easy actually. So in order to compute the resistance, okay, what we need is we need to know the supply voltage, which is 9 volt, and we need to know the LED voltage. Okay, so for this LED, I think for red LED, or there are different LED, red, green, blue. Okay, so for each LED, in order to power it properly, there is a voltage actually. Okay, so which is what mentioning here, 2 volt. Okay, this is actually the voltage drop in the LED as well, but 2 volt is necessary to properly work with this LED. Okay, so in order to find these resistance, what we are doing is we know the power supply voltage, we know the LED voltage. Okay, and then we also know the current limit of the LED. Okay, so if the current is exceeding the limit, then it will burn out. Okay, so the current limit of this specific LED is 0.02 ampere, which is around 20 milliamps, right? 20 milliamps. Okay, so if we have these information, then we can compute the resistance using this equation, R equal to V by I. Okay, so in this case, V equal to 9 minus 2. Okay, 2 is the drop of that LED. Okay, 2 is the drop, so 9 minus 2 by 0.02, which is 350 ohm. Okay, ohm is the unit of resistance. Okay, 350 ohm. So we have to find a resistor of 350 ohm. Okay, maybe we will not get an exact resistor. Okay, here you can see it's 330. Okay, so when you work with a circuit, okay, when you work with a circuit like this, if your computer resistance is 350, okay, and if there is no resistor available for 350, I will advise you to find a resistance more than that. Okay, that will be safe, but like 350, 330 will be fine. It will be fine. Okay, but I will say 360. You can find plus or minus 20 or something. Okay, in this case, so 330 is fine. Okay, so we can put a 330 ohm resistor like this. So you can find the circuit here. Okay, circuit can be like create using some wires or breadboard or PCB, whatever it is we can create. So you can see the circuit, the positive goes here and it is going to the positive terminal of the LED, which is the lengthiest one. Then the negative goes to the resistance. Okay, and it is going to the negative terminal of the battery. So it's a closed circuit and the LED is actually glowing. Okay, so there is an important point here: never connect an LED directly to a 9 volt battery without a resistor in the circuit. Doing so with damage destroy the LED. Okay, you can however connect an LED to a 3 volt or smaller battery without a resistor. Okay, I think you can understand. Okay, so and these guys are mentioning about the breadboard, which is an easier way to prototype the circuit. Even robot circuit we can prototype. Okay, so these all are the common things that you will see when you work with electronics, basic electronics. Okay, and now I just want to show you some parts and we can wind it up. Okay, I'm not talking about a lot of things today. So we have a thing called soldering iron. Soldering iron. How many of you don't heard about soldering iron? Right? Soldering iron. How many of you don't heard about soldering iron? Soldering iron. I'm just taking something, so you can just think. I mean, do you heard about soldering iron or not? Okay, Karthik. Okay, Karthik. Yes, good. I'm not sure. Yeah, if you don't heard about, you can just comment. So in the meantime, I can just take some components. Then here. Let me take. Okay. Yeah. So some of you have heard about it. Good. Let me take. Yeah, these all are resistors. You can see. Yeah, I got it. Okay, great. So I hope some of you are not heard about it. Yeah, there will be people. Okay, yeah. So I just want to show you the, I mean, the things that is very useful to us. Okay, so we have seen the breadboard, right? Breadboard. Where is breadboard? Yeah. So here is the breadboard. Okay, you can see. Okay, so breadboard is for prototyping, meaning if you want to create a circuit, for example, blinking an LED, okay, you can use the breadboard. Okay, so the advantage of breadboard is you can after prototyping the circuit, you can remove it. Okay, you can easily like pull out these things. Okay, so you can reuse this breadboard, right? Okay, so it's very I mean useful, right? You can create any circuit and you can reuse it. I mean after that you can just remove all the connection and you can reuse it. But if you're creating a robot, mostly it will not be in the breadboard. Okay, you will have a PCB, stands for printed circuit boards, maybe like this. Okay, okay, I mean a board like this. Okay, or let me check. You may have a seen board like this. Okay, right? So if you're planning to build a robot or something, mostly we will have a board like this. Okay, if you open a electronic, maybe a device or something, you may have seen this kind of circuits, right? So in this circuit you can see a integrated circuit, then LED, resistors. Okay, and that is actually the top of this board, and there are some connection on the back. Okay, so this kind of boards are called PCB, printed circuit boards. From the name itself you can understand, right? Actually the components are mounted on the top of this board. Okay, and the component connections are handling on the back. Okay, and you can see, unfortunately it's not very clear. I expected some more clarity, but it's not delivering that much. Let me try again just to improve. No, Okay, let me try to stream. Oh, restart the computer. Okay, maybe I can do it next time. So you can able to see a circuit, right? You can see a circuit here. Okay, I'm not sure it's very clear or not. Okay, right? And you can see some points here. See, there are some points here. Okay, so the connections are yeah, I can zoom it. The problem is with the camera. I mean, it's not a problem with the camera, it's a software setting. Next time I will improve. Let me see. Let me try to focus, because this is a mobile camera and I can understand it's not very clear. What I will do is I will just close. No, that is not possible. Yeah, maybe I can show this yeah, tomorrow as well. This is not very clear, so I just want to, yeah, okay, maybe I think it's focusing on the keyboard, right? Maybe that may be correct. Sorry for the disturbance actually. Yeah, now it's better. I think the keyboard is out of the picture. Yeah, so you can see, right? You can see the lines, right? And you can see the connections. Okay, so these points are called soldering points. Okay, so in this side you can see the components. Okay, and the terminals are connected here. You can see the root here. Okay, you can see the path. The circuit is crafted here or drawn here. Okay, so in order to solder means connecting the terminal of the components to the PCB. Okay, so these green color is basically it's copper. Okay, it's conducting, it's like a wire. So in order to connect these components on the back of the board, we are using copper. Okay, and these path can be path can be, we can create it our own. Okay, and then these points are connected to the copper clads using a thing called soldering iron. So this is a thing. Okay, soldering iron, we have to plug it, and this area will be heating up, and you can use this tip to connect these lines. Okay, it's not very difficult, but in order to connect, we need a thing called lead, soldering lead. So that is this. Okay, you have to buy it separately. Okay, and you have to put the lead and heat it up and put on these points. Okay, then the component leg will be connected to the PCB. Okay, so, and also if you want to desolder, there is a thing called desoldering pump. Okay, that is this. Okay, so this is like a vacuum based thing. So you have to press here, and then you can just heat the leg, and you can just suck the lead out. Okay, so that is the desoldering pump. Okay, and there is a thing called flex. Okay, I didn't open it. Maybe tomorrow I can show you that. So flex is actually using along with the soldering, which is actually removing any impurities like carbon. Okay, when you solder, there will be carbon, and that will be removed by this flex. This is like an oil kind of thing. Okay, Maybe tomorrow I will show this clearly. So mainly we have to deal with, while working with robots, we have to deal with PCBs. Okay, maybe initially you have to prototype the robot in a breadboard using wires and all, and then you have to like create the PCB. Maybe there are different kinds of PCBs available. There are general PCBs like this. Okay, so this is an add-on for Arduino board. Okay, we will be discussing Arduino tomorrow. So in this PCB you can solder, I mean there are no fixed route like this. Okay, you can solder as per your circuit. You can create your own circuit here. Okay, so so that is a convenience actually. Okay, so yeah, that is it. And yeah, so that is PCB. Just a second, guys. Okay, so yeah, so this is a PCB, and this is what we are using commonly in robots. I mean, there are different kinds of PCB. So along with the soldering iron, then soldering lead, these tools will be very, very useful. Okay, while prototyping. Yeah, I think I think we are done with today's session. Okay, I will be like putting the camera, good camera tomorrow, and then I can introduce these components again, so you will get more understanding. Okay, then tomorrow we will be seeing about the Arduino, then boards like Tivasi, Arduino, Raspberry Pi, Raspberry Pi Pico. Then if we have time, then we will be like checking with Odroid, Jetson Nano, all this board I have. Okay, so I can just introduce this board to you, which can be the brain of the robot. Okay, so in between, if you have any confusion or any doubts regarding electronics, you can ask me. Okay, because I'm just going I mean through the basics of electronics, and I'm just giving an idea. Okay, not all the things, but just an idea. Okay, so now I think we can have a Q&A session, maybe for 5 minutes, and after that we can conclude this session. So let me know if you have any basic doubts regarding the electronics components and circuits. Anyone? Any confusion? I will share these links and video today. So yeah, any confusion, guys? Any confusion? If you want to know more about electronics or any specific topic, you can just mention that. I will be discussing that tomorrow. Okay, I think it's clear to you. Tomorrow I will fix the camera, okay, for sure, because actually I could able to fix, but I need to restart. So that's what. Anyway, I will fix that. Sorry for that. Okay, so I think we can conclude today's session. Very basic. It was very basic, and we are actually coming to the brain of the robot. Okay, so Arduino, then Raspberry Pi, all this stuff, we have to use it inside the robot. So not only Arduino and Raspberry Pi, along with that we need to create a circuit as well. Okay, so in order to work with this, we need to understand how to create a circuit. Okay, and the voltage, current, all those stuff you have to clear about. Okay then, guys, we can conclude. If you have any doubts, you can put it in the Discord. Okay, yeah, that's it. That's it for today. So tomorrow the same time, 8 p.m. We can see and discuss. Okay, tomorrow I will be get back with the microcontroller, I mean the brain of the computer, microcontroller and microprocessor. and I will be like showing all these things. Okay then guys, good night. Okay, and see you tomorrow.